Right, take a look at our opener here. It says, what is the area of a circle with a diameter of 10 centimeters? So, quick reminder for your area formula. Area is pi r squared. So, unlike your circumference formula, there is not a formula that involves your diameter. So, you will just have to convert our diameter. If our diameter is 10 centimeters, that means our radius is 5 centimeters. So to find my area then, it is pi times 5 squared. Order of operations tells me I'm going to square that 5 first. So it is actually pi times 25. So we grab our calculator. Remember, for the sake of our class, I will be using the pi button. However, if you do not have a pi button, you can use 3.14. You might be off by a tenth or so. So 25 times pi, or pi times 25, we get 78.54. Looking at my units, we got centimeters. And then our unit for area is always squared. So there's our area of our circle with a diameter of 10 centimeters. So as we talked about finding that area, we just do pi r squared. Now, when we talk about a sector of a circle, we talked about looking at just a partial piece of your circle before. Your sector, it is actually that piece of pizza that you are going to be pulling out. So a sector is the region bounded by the two radii of the circle and then their intercepted arc as well. So it is truly this full piece of pizza right here that you are going to pull out. The two radii and then that arc that is the intercepted arc. So we'll be doing both, finding the area of your whole circle and then finding the area of just that sector today. Those are the two ideas that we're going to work with. So as we mentioned in the opener, to find the area of your circle, it is pi r squared. So in A, I want you to find the area of a circle with a radius of 4.2 meters. So your area is pi times your 4.2 squared. Once again, remember to square first. So we have pi times 17.64, which gives us an area of 55.42. And our unit here would be meters squared. In the second one, they have us working backwards. So they give us the area here. So in this case, pi r squared will equal my 201. First thing to do is we'll divide by pi, get that r squared by itself. 201 divided by pi gives us 63.98. And then we need the square root of each side, which gives us it gives us 8. Now, that's our radius. If you look back at the directions, they want our diameter. So if the radius is 8, the diameter will be 16. And in this case, our unit will be in inches. Now, as far as finding the area of a sector then, just like we did in finding the length of an arc, we're going to be talking about part of our circle. So, for example, if I have the area of my circle being, we'll just do something nice and easy. We'll do 20 inches squared. Well, if I take a look at a circle, the area of that circle is 20 inches squared, and I want to take 1/4 of my circle. Well, that arc angle there was 90 degrees, which means my arc was 90 degrees. So we want 90 degrees out of our 360. That's 1/4. Equals the area of our sector. This is what we're trying to find. So that'll be our x. Out of the area of the whole circle, which we just said was 20 inches squared. Now, here I know 1/4 of my 20 inches squared is just going to be 5 inches squared. But if I end up with numbers that aren't nice anymore, maybe I want 81 degrees out of my 360. That's when you're going to have this equation or this proportion to set up. So just like yesterday, we're just going to be setting up a proportion that says the area of our sector over the area of our circle will equal the measure of our sector, the measure of that arc there, AD, over 360 degrees. So just like yesterday, 3 unknowns and 1 constant. That 360 will always be there. And then they're going to give you 2 of the 3 pieces and ask you to find the missing one. The other difference here is when you look at the directions, they're going to ask for the areas of the sectors. Plural, meaning there are 2 of them. We have a shaded section and an unshaded section now. So, find the areas of our sectors formed by angle RQS. So if angle RQS is 63 degrees, then my arc is 63 degrees. So we know we have our 63 out of 360. Now, it is the area of our sector over the area of our circle. The radius of our circle was 5. So our area of our circle is pi times 5 squared. 5 squared is 25. So we do 25 times pi, and we get 78.54. So there's our equation to cross multiply. 360 times x is 360x. 78.54 times 63 is 4,948.02. Now we'll divide both sides by 360. And that tells me that x equals 13.74. Now, in my case, my x, it was this 63-degree sector. So that is our shaded portion, which is 13.74, in this case, units squared. Which means my unshaded one, I take my whole area, which was 78.54, and we'll subtract off that shaded piece, that 13.74. To give us an unshaded area of 64.8. And in this case, units squared again. So shaded was 13.74, unshaded was 64.48. I'm sorry, 64.8. So that is our idea in these problems. Take a look at your next one then. Just wants the area of our circle. Now, if the diameter is 9, that means our radius is 4.5. So it is pi times 4.5 squared. Remember, once again, square it first. 4.5 squared is 20.25. So I do that times pi. We get 63.62. And in this case, my units would be centimeters squared. In our next one, they want us to find our radius. So that pi r squared is equal to 154. First thing to do is divide by pi. We get r squared equals 49.02. And then we'll take the square root of each side. So r equals 7. And in this case, our unit is in feet. Take a look at your next one there. Find the areas of the sectors. Remember, that means shaded and unshaded. So the first one we have is 106 degrees. So that's 106 out of our 360. Area of our sector is our variable over the area of our whole circle. Well, we need to figure that out. Area equals pi times, in this case, 9 squared. 9 squared is 81 times pi. So we get 254.47. So there's our proportion to cross multiply. 360 times x is 360x. 254.47 times 106 gives me 26,973.82. Then we'll just divide both sides by 360. So x equals 74.93. And in this case, we're looking at feet squared because it's an area. And that was the 106 degree part. So that was our shaded portion. As for the unshaded then, we need to take our whole circle, which was 254.47, minus the shaded piece, the 74.93. And we get 179.54. And once again, your unit is still feet squared. A couple more examples to look at. Here it says use the diagram to find the area of circle C. So now they are giving me the area of the sector. So I'm still doing a 45 degree piece out of 360. The difference is now I need to figure out, now they give me the area of the sector and I need to figure out the area of my circle. Right, so it's the same proportion, it's just the variable changed where it was. Now we don't know the area of the circle, but we know the area of the sector. So cross multiply, 45 times x is 45x. 22 times 360 gives me 7,920. Divide both sides by 45. We get x to equal 176. And in this case, we're looking at meters squared. All right. Next example says the contractor needs to cut out a section of a rectangular piece of wood as shown. To the nearest square inch, what is the area of the remaining wood? So we start with that whole rectangular piece of wood. So I'm looking at 11 by 7. So I have 77 inches squared. Now I'm going to cut two pieces out. First I'm going to cut out the square that's here, my 3 by 3. So I have 9 inches squared that I am cutting out of it. So I am left with 68 square inches. Now the next thing I'm going to cut out is my little semicircle that's here. So I need the area of my semicircle. So to figure out our semicircle, it is 1/2 of my circle. So the circle area equals pi r squared. So it's pi times, since my diameter is 3, my radius is 1.5. So we have pi times 2.25. So the area of my whole circle is 7.07. So my area of my semicircle is 3.54. So my overall remaining area then, what is left over is 64.46 inches squared. And so just taking that whole area and cutting out the pieces that we didn't want. All right, two last examples to look at. First one says find the area of our circle. So once again, since we're finding the area of the circle, this must be the area of our sector then. So we are looking at an 80-degree sector out of my 360. The area of our sector is our 6.4. Area of the circle, that's what we're trying to find. Cross multiply 80 times x is 80x. 6.4 times 360 gives me 2,304. So then we'll divide both sides by 80. And we get x to equal 28.8. Looking at our units, we're looking at yards squared. All right, last one then. Find the area of a figure. So instead of subtracting figures out, we're going to be adding certain figures together. So we start with our triangle. Our triangle is 1/2 the base times the height. So we're looking at 1/2 of the base, which is 7, times the height, which is 4. So our area of our triangle gives me 14 feet squared. Then we come down to our semicircle that's down here. So we want 1/2 of our pi r squared. So since the diameter was 7, my radius is 3.5. So for my circle, we would have 3.5 squared, which is 12.25. So the area of my whole circle would be 38.48. But we only wanted our semicircle that was there. So I take my 38.48 and we divide it by 2. 19.24. So my 19.24 plus my 14 we get our overall area then of 33.24. Looking at our units, we're in feet squared. All right, here's our homework for tonight. Please let me know if you have any questions.